All right. So, looking at this assignment from last time, let's do one or two of these here together. Do you have a preference? Does anyone have a preference?
We do number 3.
3? Sure. All right, so looking at number 3, the first thing we want to do is write down the values for A, B, H, and K. What are those 4 values? Very good. So using that, is this growth or decay? Growth. Since the B value is bigger than 1, it's growth. Next thing we ask for is the horizontal asymptote. So that's y equals what? The -2, because that's the value for K. After that, we'll make our 5-point table. So the way we make our table is -2 plus H, and then -1 plus H, and then H, and then 1 plus H, and then 2 plus H. And then to find our values for B, or for Y, we're going to do A times B to the -2 plus K. So that's going to be -2.2 repeating. And then we'll have -2 times B to the -1 minus 2. So that's -2.6 repeating. And then we just have -2 plus, or A plus K. So that's -4. And we have A times B to the first plus K. So that's going to be -8. And then we have A times B squared plus K. So that's going to be -20. Okay. So let's go ahead and draw our graph. One, two, three, 4. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. The next thing I like to do is draw in my asymptote. So that's the horizontal line that goes through -2. And then we'll start plotting our points. So I have 0 and -2.2, 1 and -2.6, 2 and -4, 3 and -8, and then 4 and -20. So when I draw my graph, I should have something that looks like this, with arrows at both ends of my graph. And then the last thing I need is a domain and range. Well, the domain for all exponential functions is -infinity, +infinity. And then the range depends on 2 things. It depends on our values for A and our values for K. Since A is negative, I know the range starts -infinity and then it ends at K. And for exponentials, everything has a parenthesis. No brackets. Does that feel okay there for number 3? Okay. Do we want to do another? Harley? 4? Three 2/3, 1 6. 3 2/3, 1 6. Okay. So we'll write down our values for A, B, H, and K. I notice that 2/3 is less than 1, so we have a decay situation. And our horizontal asymptote will be y equals 6. Was that -6? Did I write that down wrong? I did. Sound good? All right, let's make our table. So I'm going to have -2 plus h, -1 plus h, 1 plus h, and then 2 plus h. And then to get these y's, I'm going to use my calculator now because 2/3 with the negative exponents is going to be a little rough in my head. So I'm going to have a times b to the -2 plus k. And remember that adding a negative is the same thing as subtraction. I just wrote the subtraction there. And then I have b to the -1. So that's going to be 0.75. -1.5. Because I don't need that. I can do that one in my head. That's -3. And then I have -4. And then I'm going to have like 475 or something. Oh. Close. Okay. So there's my points. So let's draw our graph. It's 1, 2, 3, 4, 5, -6. 1, 2, 3, 4. Okay. I'll start by drawing in my asymptote. So here is y equals -6. Again, horizontal line that goes through -6. And then we'll plot our points. So I have 3, or -3 and 0.75, -2 and 1.5, -1 and -3, 0 and -4, and 1 and 4.6. So I'll draw my graph. Again, remembering to draw enough of it so it looks like it's following the asymptote. So far, so good. Okay. The last thing I need is the domain and range. So the domain, again, always -infinity to +infinity. The range here, since I have to look at the a and the k. Since the a is positive, I'm going to start at k and go to +infinity. Does that sound good there, Harley? Okay. Any final questions on these problems here? Should have been relatively straightforward, right? You just kind of follow the examples that we outlined in the notes, and everything should have gone pretty well there. Nothing too tricky there. So today we're going to talk about some applications of exponential functions. So there are two kind of general exponential models that we'll use. The first one is the general growth or decay model. And the equation for this model is y equals a times 1 plus r to the t. Where y is going to be some future value. A is going to be like our starting value. R is the rate of change. And it's important that we write this as a decimal. And then t is time. The second model is the compound interest model. Yes.
Sorry to interrupt you. This motion has been already now.
Oh, sure. Okay. So the compound interest model is FV equals PV plus R over N to the NT power. Where FV is our future value. PV is the present value. R is the interest rate, written as a decimal. N is the number of compounds per year. And T is equal to time in years. Yeah, I can pause here for a minute. Sure. Okay, so in this section here, we're going to be really kind of answering questions about story problems. And the tool that we're going to use is going to be one or the model or the other. In general, the way to tell them apart on which model to use, the compound interest model we would use when the question is about banking. And we'd use the other model in all the other situations. So if it's a banking question talking about like investing money in a bank account, that's a compound interest problem. Anything else will use the other model. Sound good? Okay. So we'll do, let's say, 3 examples here. So each of these 3 examples, I'm just going to kind of write up a situation. And then we'll ask a series of questions about that situation. Okay? So the situation is in 1996, there were 2,573 computer viruses. During the next 7 years, the number of viruses increased by 92% each year. So that's the situation that we're going to be using. The first thing that we're going to ask is to write an exponential model for the number of incidents n t years after 1996. So since this problem has nothing to do with banking, I know that I'm going to be using the general exponential growth or decay equation. And now what I'm going to do is fill in the appropriate values into this equation. So remind me again, what does y represent in this equation? A future value. Okay, so what is our future value going to be in this situation? Read part A again. Nope, a future value is going in place for y. So what are we going to put in place of y? Nope, not 7. Not 92. Not 2,573. Not 1996. It tells you that the number of incidents after 1996, that's a future value, right? Tells us the symbol that we're going to use for that is n. So in place of y, I'm going to write the letter n. Is everybody okay with that? The number of incidents is n t years after 1996. That is a future value, right? That's the future amount of computer viruses. Okay? So that's going to be what we're going to put in place for n. What is the starting value or the present value? They're very good. 2,573. Okay. What is the rate of change here? 0.92. The 92% tells us the rate of change, but we need to make sure we're writing that as a decimal. So 92%, if you divide that by 100, converts it into a decimal of 0.92. And then the t represents time. In the part A, it tells us to use t for the number of years after 1996. So I don't have to do anything there. I'm just t is t. So this is my exponential model. When you write a model, you're always going to have two variables in it. In this case, we have n and t. Everybody's okay with that? Part B now says, use your model to estimate the number of viruses in 2003. So this is my model. I'm just going to recopy that. What letter are we looking for here? N or T? Read the part B again. We want the number of viruses, which is n, right? So to solve for n, we need to plug in a value for t. Everybody's okay with that? What value of t do we need to plug in? Very good. So Harley says it's the number of years between 1996 and 2003, which would be 7. So I'll plug that in and then go to my calculator and type this in and see what I get. Oops. So I get 247,484.7182. How should I round that value? What would make sense in a real world context? Where would I want to round this to? Would want to round it to the nearest whole number. Very good. Why would I round it to a whole number? Yeah, because viruses are either you have a whole virus or you have no virus. You can't have half of a computer virus, right? So rounding it to the nearest whole number seems to be the most reasonable thing to do. Everybody feel okay there? Okay. So part C says use your model to estimate when there will be 125,000 computer viruses. Okay. Well, it says to use our model, so I'm going to start by writing our model down again. So which variable is it asking us to solve for in this problem? T. How do you know it's going to be T? Well, the question is a when question, right? When is a time, right? So we're going to solve for T. In order to solve for T, we have to have a value for N. What is our value for N here? 125,000. Are we okay to hear? So we need to now solve this equation for T. Can we do this algebraically? No. It turns out that we don't have enough tools right now to be able to solve this algebraically. One of the goals by the end of this chapter is that we do work out the tools to solve this purely algebraically, but we're not there yet. However, we did develop a technique in first semester that we can apply here to be able to solve this. So what we're going to do is we're going to rewrite this as a system of two equations. The first equation is just going to be our model. And the second equation is going to be that future value we're trying to figure out the time for. So if you remember back to first semester, when we solved systems of equations, one of the methods we talked about was graphing. What did the solution to a system of two equations look like graphically? Does anybody remember this? So when we graphed a system of two equations, what did the solution look like? Where was the solution at? When they intersect. Exactly right. So we're going to use our calculator to graph these two equations and find their point of intersection. And that point of intersection is going to give me the information I need to solve this problem. Is everybody okay with that plan? If you have your graphing calculator with you, I'd invite you to take it out and kind of follow along as we'll talk through how to do this again. If you don't have your calculator with you, that's fine, or if you'd prefer to just sit and pay attention, that's okay. I would suggest to you, though, when you're going to do your homework, if you don't remember how to do this, to queue up this part of the video and just watch the buttons again if you need to. But we'll run through it right now together. All right, so we'll take our calculator out and turn it on. Where do I have to go on my calculator if I want to graph something? The y equals. Very good. So I'm going to start by pressing the y equals button. And then anything that's in there I'm just going to get rid of. So if I have any equations in there, I'm going to clear all of those out. And then I'm going to check one more thing. Up at the top of my y equals menu where it says plot 1, plot 2, plot 3, I want to make sure that none of those are highlighted. Notice on my screen, none of those are highlighted. So check your calculator real quick to make sure that none of them are highlighted. If they are highlighted, just use your up and down arrows to move over to the appropriate spot and press enter to unhighlight it. Okay. So what I'm going to do now is I'm going to type in this system of equations into my calculator. So on my calculator, I'm going to use the y variable instead of an n, because the y is already built into my calculator there. And then I'll do 2573 times 1.92 to the, and instead of t on my calculator, I have to use the variable x. So I'm just going to put an x there. Is everybody okay so far? And for the second equation, again, I'm using y instead of n. And then I'm just going to type 125,000. Everybody okay there? Good. Before I hit graph, though, I need to do something else. What I need to do is to set a window. Because more likely than not, if I just hit graph right now, I'm not going to see anything. So I'm going to press the window button, which is right next to the y equals. And now we have to think a little bit about the context of this problem and what we know that's going on. So remember, we're using the variable x to represent t, which was the time. So what's going to be the minimum value that we could have for time? I would say 0, right? What would 0 time represent? The year 1996, right? The start of the problem. Everybody's okay with that? All right. What would I pick for the maximum value for time? 7, which would represent the year 2003. If I go back to the very beginning, it says for the next 7 years, computer viruses increased by 92%. So I know that my model really only lasts for 7 years. Everybody okay with that? Next, I'm going to go to the y's. So remember in our problem, y is representing that future value for the number of computer viruses. What is the minimum value for the number of computer viruses we can have? $2,573. We know that the number of computer viruses is growing, so the starting value is going to be the smallest amount of computer viruses we have. You know what? For the sake of argument, let's just make that a round number for 2,500. I'm just going to round down a little bit. Everybody okay there? Just in terms of making it neater. And what's the most number of computer viruses we can have? Well, over 7 years, go back and look at part B. Yeah, so I'm going to round that up just in terms of making it a little bit of a nicer number and put 250,000 there. Now that I have my window set, now I'm going to go ahead and hit graph. So you'll see the curved line coming in now. This is the first equation. And the straight line coming in second, that's the second equation. And what I'm interested in doing is finding that place where the two are intersecting. So right where my mouse is. Everybody's okay with that? The calculator can do this for us. So what I'm going to do is I'm going to press second and the trace button. The trace button is there on the top row. This menu is full of commands that I can do on the graph of a calculator. If I look at these commands, which one sounds like the one that I'd be interested in? Intersect. So let's scroll down and select the intersect command. I press second and trace. Okay, so you notice on my screen now the calculator is going to ask me some questions. The first question it asks is for first curve. So the calculator needs to know which two curves am I looking for an intersection on. So you'll notice that I also can see a cursor. See the cursor flashing there? So one of the two curves I want is this one. So I can press enter anywhere on that curve. It doesn't matter. So right where the cursor is at is fine. I'll press enter. Notice that my cursor is automatically toggled onto the next curve. And the calculator asks for the second curve. What's the other curve we want to find the intersection with? Well, my cursor's on it. So I'll just press enter again. And then it says guess. So I'm just going to use my left and right arrows to move my cursor close to where that intersection is. That looks close enough. And then press enter again. So what the calculator then says is your point of intersection is x equals 5.9529 yada yada yada. Y is 125,000. So there's my answer. What is my value for t then? It's the same as my value for x, or about 5.95 years after 1996. Is everybody okay there? Okay. Let's do another example. So in this problem, we have that a new snowmobile costs $4,200, and the value of the snowmobile decreases by 10% each year. The first thing we want to do is write an exponential model for the value of the snowmobile, V, t years after the purchase. So, which model should I be using for this situation? Is this about bank accounts? No. So we'll use the general exponential model. Okay. What are we going to put for y? V. Very good. That's the future value of the snowmobile. What are we going to put for A? 4,200. That was the purchase price of the snowmobile. What are we going to put for R? Close. It's not 0.1. Read the problem there again a little bit more closely. Specifically, the few words in front of 10%. Negative 0.1. Why is it negative this time? Because it's decreasing. Very good. Okay. And then it says for time, we're just using t. So here's my model. Is everybody happy with this? So the next question says, what is the value of the snowmobile 3 years after its purchase? Well, to do this, we're going to use our exponential model that we just wrote. Which letter are we looking for, V or T? V. Okay, to find V, we need to plug in a value for T. What value of T are we going to plug in? 3. Hopefully that's clear to everyone how we got that. So we'll just type this into our calculator now. So I get $3,061.80. The next part says to estimate when the snowmobile will be worth $2,500. Well, again, we're going to be using our exponential model that we just made to answer this question. What letter are we looking for here? T. Okay, in order to solve for T, we need a value for V, which would be, good, 2,500. And to solve this equation, we're going to have to use our calculator to graph it and find the intersection, right? So let's cue that calculator back up. We'll go back to the y equals, and we'll type in our exponential model. and the future value that we're interested in. Everybody okay there? Okay. I'll go to the window, and now we need to pick some values. So X we put in is representing time, the number of years after we've purchased the snowmobile. So what's a good minimum value for that? 0. 0 time would represent the value at purchase, right? How much it cost. What would be a good upper bound for X? What? What number did you say? 3. Okay. So what is the value of the snowmobile after 3 years? It went from 4,200 to 3,000 and change. We still haven't gotten to 2,500, right? So we know that whatever this number is, it needs to be bigger than 3. Do we know specifically how big of an upper bound we should pick here? No. If you were to take a guess of getting it at least past 2,500, what number would you pick? 6 sounds wonderful. It's just kind of a guess. We don't really know. Anything bigger than 3 is probably reasonable because we were pretty close at 3 years, but 6 should definitely get us there, right? Okay. All right. So now we're going to pick our Y mins and Y maxes. Remember, Y is going to be the value of the snowmobile. So what's a good minimum value for the snowmobile? 4,200 would not be the minimum. That would be the maximum in this case. The minimum would be 0. Yeah, what kind of an exponential situation do we have here? This is decay, right? It's going down. The least value that your snowmobile could ever have is 0 when it's just a big rusted pile of junk, right? Does everybody feel okay there? Okay, so let's hit graph and take a look. So this first line coming in is the value of our snowmobile. There's 2,500 is the straight line. So we're looking for that point of intersection. So we'll press second and trace, pick the intersect command, enter on the first curve, enter on the second curve, and then scroll over for a guess. So our answer then is about 4.92 years after purchase. Do we feel okay on this one? Okay. Last example. Okay, so this third situation says you deposit $4,000 into a bank account that pays 2.92% interest compounded quarterly. What is the value of the account after 5 years? Which of the two models should we use in this situation? the compound interest formula. This question is decidedly about banking and bank accounts, right? So that formula was FV equals PV plus 1 over N all to the NT. So what are we looking for in part A? The future value, right. How much is that account going to be worth in 5 years from now? Okay. So what are we going to fill in then for PV? $4,000, right. Whatever is in the bank account right now, that would be the $4,000 you put in there. Okay. Next thing we need is the interest rate, R. What is the interest rate? So the interest rate is 2.92%, but we need to write that as a decimal, which would be not 0.292, 0.0292. Remember, you have to divide by 100 to convert a decimal or a percentage into a decimal. And then N is the number of compounds per year. What is the value for N here? 4. How did you get 4? Because it says quarterly. If I chop something into quarters, it's into 4 pieces. So N is 4. And then T is time in years. So what should our value of T be? 5. Everybody okay here? Okay. So let's go ahead and type this into our calculator and see what we get. So how should I round this answer? I would round it to 2 decimal places. Why? What is the quantity here? It's money. How do you round money? To the penny, right? That should be kind of common sense, right? That's as far down as you can subdivide money. So our next part here says, when will that bank account double in value? What letter are we trying to solve for here? T, because it's asking a when question. Okay. Okay, so we're going to solve for T. But to do that, we need to have a future value to plug in. What future value should we plug into this? Not 4,626.33. 8,000. How did you get 8,000? It's doubling in value, so 4,000 times 2 is 8,000. Everybody okay there? So again, are we seeing the pattern on these questions that it really, really helps if you read things carefully and closely? More often than not, the information you need is in words there, and you can't just skim through looking at numbers. You have to really read. And I know it's tempting to just cruise through, look for numbers, but really got to read these things. It makes life much easier. Okay, so we'll go to our calculator now and graph this and find the intersection. Okay. So back to our window. Once we've got that in there, remember x is time, so what's a good minimum value for x? 0. That would represent like the moment we put that money in the bank. Now, notice after 5 years, we got to 4,600. We want to get to 8,000. So what might be a decent upper bound for x? What? 20 might still be a little low. I mean, I would, like, here's the deal. I would say I'd rather overestimate than underestimate when I do the maximum. I might try 50 or 100 here, to be honest with you. I'd rather have it too much out there than not far enough, because it just makes it, I don't have to go back and change it if it's too small. Caden? Okay. Yeah, so for the y's, we are going to start at 4,000, right? That's the minimum amount we're going to have. And I want to get to at least 8,000, but I need to be able to see that 8,000 line, so I need to pick something bigger than 8,000 here. So 10,000 seems like a nice round number. Let's do that. And we'll hit graph. So this first curve is my bank account value. And then this flat line is the 8,000. So there's my intersection here. So second, trace. Pick the intersect command. First curve, second curve, and guess. So 23.82. So 20 was a decent one, but it wouldn't have been far enough there, Harley. You see why, again, you'd better to overestimate than under, because if you can't see the intersection, you need to go back and change your window. So I usually always try to overestimate than underestimate. Okay. Everybody feel okay there?